Hi, welcome back. We're going to continue our exploration of special computer science functions by talking about quotients and remainders. A motivating question is, how many times does B go into A? For example, how many times does the number 6 go into the number 22? We can break 22 objects into 3 groups of 6 with 4 left over. As an equation, we would write 22 is equal to 3 times 6 plus 4. This number 3 is called the quotient, and the number 4 is called the remainder. Notice that no matter how many objects we're dividing into groups of 6, the remainder has to be one of the numbers 0, 1, 2, 3, 4, or 5, because if it's larger than that, we would have one more group of 6 hanging around. So the remainder is always going to be less than 6. Let's do a couple more examples. How many times does 29 go into 100? Well, we see 29 times 0 is 0, 29 times 1 is 29, 29 times 2 is 58, 29 times 3 is 87, and 29 times 4 is 116, and 100 fits in right between 87 and 116. So we can see that 100 is 29 times 3 with 13 left over, so the quotient is 3 and the remainder is 13. Here's another example. How many times does 11 go into negative 53? We can use the same method we used above. We multiply 11 times negative 2 to get negative 22, 11 times negative 3 to get negative 33, 11 times negative 4 to get negative 44, and 11 times negative 5 to get negative 55. And we see that negative 53 fits in right here. So just as above, we find the product that's just above where we inserted negative 53. And we write negative 53 is equal to 11 times negative 5 with a remainder of 2. So the quotient is negative 5 and the remainder is positive 2. This is part of a more general situation that says that for any integer a and any positive integer b, there are unique integers q and r such that a is equal to q times b plus r, and r is at least 0 and less than b. If we wanted to put that into words, we would say q is the smallest integer such that q times b is greater than or equal to a. If we want to find q and r, then we can apply the method from the previous page. When a is positive, we subtract some number of multiples of b until the result lies between 0 and b minus 1. That number of multiples that we subtracted is q, and the leftover piece is our remainder r. If, on the other hand, our a is less than 0, we need to add some number of multiples of b until the result lies between 0 and b minus 1. If we multiply by negative 1 this number of multiples, that's q, and the leftover remainder is r. It's very important to recognize that r must be greater than or equal to 0. You cannot have a negative remainder. A more computational way to compute q and r involves the floor function. To find q, we compute the floor of a over b. And once we have q, we can find r because we know that a is equal to q times b plus r. And if you solve for r, you get r is equal to a minus q times b. You plug in the value of q, and we see that r is equal to a minus the floor of a over b times b. Let's do some examples. If a is equal to 101 and b is equal to 6, to find q, we take 101 divided by 6, take the floor of that, and we get 16. Then r is equal to 101 minus 16 times 6, which is equal to 5. If we put that all together, we see that 101 can be written as 16 times 6 plus 5. 16 is the q and 5 is the r. It's a positive number, strictly less than 6. Let's look at an example with a negative number. A is equal to negative 10, b is equal to 14. If we take the floor of negative 10 divided by 14, so the floor of that is equal to negative 1. We apply our formula. A is negative 10, q is equal to negative 1, b is equal to 14, and we get that r is equal to 4. We put this in an equation. We see that negative 10 can be written as negative 1 times 14 plus 4. Negative 1 is the quotient, 4 is the remainder. Now we have special names for the quotient and the remainder. The quotient, when a is divided by b, is written a div b, or a // b. The remainder, when a is divided by b, is called a mod b, and this can be written as a%b, as you may have seen in Python. So when we see a is equal to q times b plus r, this q is the a div b, and r is the a mod b. As functions, we see that div takes in two numbers. It takes in the a and it takes in the b. A can be any integer, but b can only be positive integers. And when we take a div b, the answer lies in the set of integers. Similarly, the mod function takes in two numbers. It takes in any integer and then a positive integer, and the output is a natural number. It's a little bit more natural to think about these functions as div b and mod b. So while div takes in two numbers, div b would be a function that starts off with an integer and then calculates a div b, which would be an integer itself. So for instance, if b is equal to 10, then the div10 function takes the floor of a over 10. This function is not an injective function because all the numbers between 10 and 19 all give 1 as the quotient when dividing by 10. This function is surjective because no matter what number in the codomain we want to be the answer, then b times k div b is equal to k. Do know that when b is equal to 1, that's a special case. A div 1 is always equal to a, and so that would be an injective function. The mod b function, it takes in a, it gives us a mod b, and those remainders we said can only be numbers between 0 and b minus 1. And we'll notice that mod b is not injective. If we take mod 10, numbers like 12, 22, 32, etc., mod 10 are all equal to 2. And at the same time, mod b is surjective because 0 mod b is equal to 0, 1 mod b is equal to 1, all the way to b minus 1 mod b is equal to b minus 1. So everything is hit, and so mod b is a surjective function. That's it for this video and for the topic of functions. See you next time.